Catholic High Prelim paper for 2024. This is for paper 2. So calculators will be allowed. Question number 1. We have a square grid. It shows the points A, B, C, D, E, F, and G. So which point is east of B? Which point is east of B? Okay, you have the compass at the side showing the north point. Then this will be south, west, and east. And you want east of point B. Of point B means taken from point B. That's your north, which means that we want east, which is this direction. Okay, so answer is point C. So C is the east of B. Okay, not G. G is the west of B. Okay, there is this missing letter here. This letter is supposed to be F. So Alicia stood at one of the points facing point D. After she turned 45 degrees clockwise, she faced point F. Which point was Alicia standing? Okay, now the thing is, whenever you're given a grid, right, it's almost always that, in fact, it's always like, okay, it's either it goes along the horizontal or vertical lines of the grid, or it can go diagonally. So when it goes diagonally, right, it will always cut like at 45 degrees only. Okay, so the clue is that we have Alicia standing on the points facing D. Facing D, right? You look for the points that are either like along the horizontal or vertical lines of the grid or diagonal. Okay, so from facing point D, it's definitely not from F, because F to D, right, the diagonal does not cut at 45 degrees. If it cuts at 45 degrees, it will be cutting this way. Okay, so F is definitely out. So we're looking at either A, B, or E only. Okay, G is also out. G, when you cut diagonally, it doesn't cut to D. D from G diagonally is like here. Okay, so we're looking at either A, B, or E. So she's standing either at A, B, or E, and she's facing D. After she turned 45 degrees clockwise, she faced F. So which point was she standing at? So now what you do is you only got 3 options. You test out the points. So if she's standing at A and she's facing D, then 45 degrees clockwise will be facing F. So the answer is A. Okay, let me show you what I mean. So if let's say she's from A, and if she is facing D, then 45 degrees clockwise is like that. A clockwise. Now if she turns 45 degrees clockwise, she'll be facing F, which is what we want. Okay, so answer is point A. What about the other points? Let's check. If she's from E facing D, then to turn such that she's facing F, right? This is also 45 degrees, but this is anti-clockwise. Okay, this direction. Okay, let me just show you in another color. So this, if let's say she's facing D, then this turning this direction would be anti-clockwise. Okay, so that one is wrong. Then if she's at B, she's facing D, then to turn to face F, F is not within the diagonals, the 45 degree diagonal to B, so it's definitely out lah. Okay, from facing D and then turn to F, it's not 45 degrees. Alright, so answer is A. Now question 2. Question 2 I can't show you over here because you need a protractor and a ruler. So the answer for this should be 8.8 cm for A, and then 107 degrees. Question 3. The ratio of the length of stick W to the length of stick Y is 9 to 8. Find the length of stick W. Okay, so we have two sticks here. W is 9 units. Oops. Okay, 9 units. Then Y is 8 units. So looking at the diagram, 9 units plus 1.7 is actually the same as 8 units plus 2.9. Okay, so 9U plus 1.7 is the same as 8 units plus 2.9. With this, imagine this is like a balancing beam, whatever, and the pivot is at the equal sign. So in order to balance this, whatever you do on the left side, you have to do on the right side as well. Okay, so what you do on the left, you have to do on the right. So what you want to do is, you can choose what you want to take away. Over here, I want to take away 1.7. Okay, if I take away 1.7 on both sides, I'm left with 9 units on the left side. Right side, I'm left with 2.9 minus 1.7, which is 1.2. Okay, so with this, looking at the equation, I know 1.2 has to be 1 unit, because 8U plus 1U gives me 9U. So this has to be 1 unit. So with that, I have 1 unit, which is 1.2. Question is asking for the length of W, which is 9 units. So 9 times 1.2. Okay, so answer 10.8 cm. Question 4. Terry used 1 cm cubes to form a cuboid measuring 45 cm by 30 cm on, 45 by 30 by 20 cm. He painted all the faces of the cuboid. So how many of the 1 cm cubes in the cuboid have only 2 of the faces painted? Okay, so first, maybe I just draw so that it's easier to understand. Okay, so this is a cuboid. This is 45. This is 30. This is 20. Now, if he paints everything, right, where are the cubes with 2 of the faces painted? So we are looking at this part here. Okay, the cubes somewhere there. Cubes here. Cubes here. Here. These parts. Okay, and then behind the hidden part. Not the corners. The corners would have 3 sides painted. Okay, so let's look at this part first. Okay, that one is, the number of cubes would be 45 minus 2. You minus away the 2 corners. 45 cm, every cube is 1 cm. So 45 cm minus 1 minus 1. That's 43. Now, 43, there are 4 of them. 1, 2, 3, and then behind there's one more. So 43 times 4. 172. Okay, so this part here, those in blue. Okay, next, let's use this. We have along the 20 cm, right? This part here, that is 20 minus 2. So that's 1, 2, 3, and then behind there's one more hidden one. So 18 times 4, which is 72. Okay, 72. And then lastly, you have this part here, this one, and the bottom one is hidden. That is 30 minus 2, 28. Then 28 times 4 of those, which is 112. Now add all of them up. Okay, we want to add this, and this one. 172 plus 72 plus 112. This will give us 356 cubes. Okay, so those are the cubes with two sides painted only. 356 cubes. Okay, question number 5. Now this I would suppose this is a more challenging question. Not that it's difficult, but there may be towards the end there is a part that maybe some students may not be able to pick up. Okay, so let me go through question 5. Daryl has a roll of stickers. There is a total of 55 star-shaped and heart-shaped stickers on it. At least 3 star-shaped stickers are found between any 2 heart-shaped stickers. What is the largest possible number of heart-shaped stickers on the roll of stickers? Okay, so firstly, let me explain this sentence. At least 3 heart-shaped stickers are found between any 2 heart-shaped stickers. So, meaning, if I have 2 heart-shaped stickers, right, in between, I can have 3 stars. Okay, I can also have 4. I can also have 5. Now, the thing is, there must be at least 3. Okay, nothing less. So, as long as you have 2 hearts, there should be at least 3 in between. So then how do we know? How should we determine like how many stars are there in between the heart-shaped stickers? Okay, question is asking for the largest possible number of heart-shaped stickers. So if you want this is what we call an interval, okay? The gap between 2 heart-shaped stickers. So if you want as many heart-shaped stickers as possible, right? Then the number of intervals have to be the greatest, correct? The more intervals there are, the more heart-shaped stickers there are. So if we want the most number of heart-shaped stickers, there'll be the most number of intervals, which means that the number of stars, when we spread them out, we should try and put the least number of stars in between, okay? Only then can we have more intervals. If we try to squeeze like a lot of stars into one interval, then of course the number of intervals will be fewer, right? And that means that the number of heart-shaped stickers will be fewer. So we don't want that. Okay, you want to squeeze fewer number of stars. Okay, so with that, I know that by default, I should have 3 stars in every interval, the least number. Okay, so it will look like that. And then 3 stars, and then a heart shape, then 3 stars, and heart shape, and so on. So let me group this up. This will be one group. This is more of a grouping concept rather than the interval concept because we are given the total number of stickers. Okay, if we are given number of heart shapes, then it will be more of an interval concept. But if we are given total number of shapes, then you need to find a way to group them up. Okay, so in one group, there is one heart shape, 3 stars, so 4 stickers. Okay, 4 stickers. Next, I'll find number of groups. So if there's a total of 55 stickers, I'll take 55 divided by 4. which is 13. Then find the remainder, which is a 3. To find remainder, once you get the answer 13 as the whole number, right? 13 times 4 will give you 52. Then you should have a remainder of 3. So remainder is 3. Now, I think most students should be able to get up to this step, right? But what do you do with the remainder of 3? Now, the remainder of 3, take note that, okay, so 13 groups means that I have 13 of this, right? 13 of the heart shapes, and then 13 times 3 stars. So the very next shape by right should be a heart shape, right? So this one, we are expecting like heart and then 2 stars. But actually, it's not that, because you have to end off with a heart shape at the end. Okay, so what it will look like is like that. So in you have many groups, and then this is the last group. Okay, the 13th group of shapes, but you must end off with heart shape, because it has to be between any 2 heart shapes. You have stars, right? So you must end off with a heart shape. So the heart doesn't necessarily have to be the next shape. So for the 3, it's actually like that. Okay, so this is your last 3 shapes. So can you see in my 13th group, my very last interval, because they say at least 3, so I can actually put more stars in the last interval. So in this last interval here, I will end off with 2 more stars and then a heart at the end. You have to end off with a heart in the end. Okay, because questions say like star shaped stickers found between any 2 heart shape. So you can't have stars at the end. It must be between the heart shaped stickers. Okay, so if this is my last part for the remainder of 3, right? Then the number of hearts will not be just 13, but instead it will be 13 plus 1. Okay, so answer 14. This is that extra 1. So answer is 14 heart-shaped stickers. All right, next question. Question 6. EAD is a triangle, and then you have a parallelogram. AB equals to BE. AB equals to BE. So you have isosceles here. It's supposed to find angle EAB, this one here. So take note, for parallelogram, opposite sides are equal, and we also have parallel lines. Okay, so firstly, let's mark out all the angles that we know. This is 73. Opposite angles in a parallelogram will be the same. Then next we have parallel lines. So you have a Z. I'm looking at this pair of parallel lines. Like that, alternate angles. So a Z, which means that this is 39. So now using triangle, sum of angles in a triangle, I want to find this angle here. Okay, looking at triangle EBD. So angle that is EBD BD, 180 minus 73 minus 39 degrees. 68 degrees. Okay, then from there, I want to find angle ABE. which is this angle here. So 180 minus 68. 112. Then in order to find this angle, we use the isosceles triangle. Okay, so 180 minus 112, then divide by 2. So that is angle EAB. 180 minus 112. The whole thing divide by 2. So this will give us 34 degrees. Okay, so this is 34 degrees. Okay, next. Question 7. Oliver had 130 cm of wire. He used some of it to make the figure as shown. How much of the wire did he use to make the figure? Expressed in terms of P in the simplest form. All right, now to find what he used, right, we just add up all the sides. So 2P plus P plus 6 plus 3P minus 4, then plus P. Okay, so I want to combine. The sign will follow the number behind. So I will shift them, 2P plus P plus 3P plus P. Then I have my plus 6 minus 4. Two P plus P is 3P, 3P plus 3P, 6P, then add one more, 7P. And plus 6 minus 4, that's plus 2. So this is the answer in terms of P. 7P plus 2 cm. For part B, after making the figure, Oliver had P cm of wire left. What's the value of P? Now, so this amount that he used plus the amount left would give us 130, which is the original total. So let's form an equation. 7P plus 2 plus P equals to 130. So 8P plus 2 gives us 130. So what is 8P? 8P would be 130 minus 2. 128. To find P, it's like finding 1 unit. So you divide by 8. And this is 16. So the value of P is 16. For question 8, A, B, H, E, and B, C, D, F are rhombuses. CGF is a straight line. Find angle BGF, which is over here. Okay, so take note that we have rhombuses, which means that you have 4 equal sides for each of them. And you also have parallel lines. Okay, so firstly, this 219 degrees, right? And this 105 degrees, you can use angles at a point, which is 360, to find this angle over here. Okay, or find this angle over here. Now, okay, what I'm trying to do is to find this angle here. Then I'll take 106, which is this angle here, to help me find this GBF. Then because I have isosceles triangles, okay, let's mark out all the equal sides first, so that it's easier to see. These are equal. So are these. Okay. So what I'm trying to do is, in order to find this angle, I'm using this triangle here. And then I'll minus off this angle and this angle. Okay. Okay, let's find this angle first, CBG. CBG 360 minus 219 and 105, which will be 36. So this angle here is 36. I'll use different colors. Then next, this is 106 because this is a rhombus. Opposite angles are the same. So 106 minus 36 will give me this angle over here, which is GBF. Okay, that's 70 degrees. Then I have isosceles triangle here. So I will take 180 minus of this 106. Then I divide by 2. That is to help me find this angle here, GFB. So 180 minus 106 divide by 2, which is 37 degrees. So this angle here is 37. Then from here, I have the triangle BGF, and I can find angle BGF, okay, which is what I want, angle BGF. So you minus 70, not 105, 70, and minus 37. So answer 73 degrees. Okay, this angle here, BGF, is 73 degrees. Okay, question number 9. The bar graph shows the types of sandwiches sold in at a stall in the morning. Number of sandwiches sold is not shown on the scale. So on the scale, it's not given any numbers. 25% of the sandwiches sold in the morning was cheese. Draw the bar that shows the number of cheese sandwiches sold in the morning. Okay, in this exam paper, this part here is not removed. This is actually the answer that was already drawn, not removed from the photocopy. But anyway, let me just explain how we get the answer for the bar graph. Okay, so firstly, we take one interval as 1 unit. Okay, so sorry, the marking will be 1, 2, 3, 4, 5, 5 units. But I can't tell if it's like 5 or 10 or 50. So I'll just use units to represent the values. So 25% was cheese, which means that the rest of them will be 75%. So let's find out what's each of them. For tuna, it's 9 units. Sardine will be 14 units. And egg will be 7 units. So when we add them up, we get 30 units, and that's 75%. The cheese is 25%, so I'll find 25%. So I can do this without finding 1%, because I can just divide by 3. Okay, then you get 10 units. So you're supposed to draw a bar graph that reflects 10 units. That's why it's up to here. Okay, then just shade it all the way down. That's for part A. Now part B, the cost of a tuna sandwich, a sardine sandwich, and an egg sandwich was $3, $2, and $1 respectively. Total of $248 was collected from the sale of the 3 types of sandwiches sold in the morning. So how many tuna sandwich was sold in the morning? Right, okay, so we have the cost of each sandwich, okay, like one of each. And we also have the total amount of money that is collected. From the bar graph, we have the ratio of we would be able to find the ratio of the quantity that is sold. Okay, not exactly the number of sandwiches, but the ratio of the quantity. So we are only looking at tuna, sardine, and egg. So ignore the cheese. Okay, so tuna sandwich and tuna, sardine, and egg in terms of quantity, like the number of sandwiches, would be in the ratio 4 to 14 to 7. And then we have the cost of each. So I'm going to use the quantity value table. Okay, so firstly, label down quantity value, total value. So this is like a grouping question. You may have presented your information in a different way. That's fine. So just take note that it's a grouping question. Okay, so you have tuna, sardine, and egg. According to the graph, the ratio of the quantity is 9, 14, and 7. Okay, quantity is talking about number of sandwiches. Then the value is talking about the cost of each sandwich. Okay, just one of it. For tuna, it's $3. And this is 2, and this is $1. So in a group, this whole thing will be one group. In a group, I have 9 tuna sandwiches, which will cost 27. So 9 times 3. 14 sardine sandwiches, so 14 times $2, which is 28. Then lastly, 7 times $1 is $7. So in one group, what are we supposed to find? Question gave us the total amount collected from all 3 types. So I should be finding the same thing, which is the total amount in one group. Basically the total value. Okay, so I'll add them up. So in one group, the value I have is $62. But the total amount collected is 248. So how many groups are there? So number of groups would be it is 248 divide by 62, which is 4. There are 4 groups. Then go back to the question. How many tuna sandwich was sold in the morning? The number of tuna sandwiches sold will be the quantity, which is this 9. In one group, there are 9 tuna sandwiches sold. So since there are 4 groups, then we'll take 4 times of that. Okay, and you have 36. Answer, 36 tuna sandwiches. Question 10. Elliot and Fred started jogging at the same time from point R to point Q along a 9,000-meter route. So after 40 minutes, Fred was at a halfway point, which is point Q, and Elliot was at a distance behind Fred. So maybe like somewhere here. Okay, this part. Then Fred, who was at Q, he reached point R 10 minutes before Elliot. Both did not change their speeds throughout. So what's the distance between Elliot and Fred when Fred was at a point Q, which is the halfway point? So what we're trying to find is this. Okay, that's the part that we're trying to find. So we want to find distance, right? The distance between them. So what we'll do is we'll take the distance for um Fred. Okay, the distance for Fred, which is basically 9,000 divided by 2, and then minus away the distance covered by Elliot. Okay, so we want to know what is the distance covered by Elliot, which means that I need to find a way to calculate what is the speed of Elliot. Okay, and also the time taken for Elliot. Okay, so firstly, we know that Fred is at a halfway point after 40 minutes. Okay, and I don't know how far away Elliot was, but I know at the end here, Fred would have covered 9,000 meters in 80 minutes because it's double, right? Double. Okay, so let's write down first. Time taken. For F to complete. So 9,000 meters. That would be 40 minutes times 2. Okay, 80 minutes. Then the question also mentioned that Fred reached point R 10 minutes before Elliot. So when will Elliot reach the end? So Elliot will take longer, right? So time taken for E to complete would be 80 minutes plus 10, because he's 10 minutes slower, right? Okay, total 90 minutes. Why I'm doing this is because I know by the time Elliot reaches the end, he would have covered 9,000 meters. So then I can find the speed, because speed is distance divided by time. So Elliot's speed, (9,000) divided by 90 minutes. Okay, this is meters, this is minutes. So you end up with 100 meter per minute. Okay, 100 meter per minute means I can find the distance that Elliot covered. Because in this distance that he covered, right, he took 40 minutes. Okay, remember question said after 40 minutes, Fred will be here, Elliot will be here. So 40 minutes, how long would Elliot cover? So distance by E in 40 minutes. So distance is speed times time. So 100 meter per minute times 40 minutes. 4,000 meters. And as we said earlier, the distance by Fred in 40 minutes would be half of 9,000. So 9,000 divided by 2. 4,500 meters. Okay, then I can find the difference now. Okay, 4,500, which is covered by Fred, minus away 4,000, which is covered by Elliot in 40 minutes. So answer 500 meters. Question 11, we have a patterns question. The first four figures of a pattern are shown below. Table here shows the number of white and gray circles used for each figure. We're supposed to fill in this figure number 5 for part A. Okay, what's the pattern here? Now, the gray for figure 1 and 2 is the same. And then after that, suddenly it became one more layer, but we add how many? We add 8 more. We add 8. Okay, then after it remains the same. Then after it's going to add one more layer after that. So what do you notice about the number of gray circles or white circles? They will always form a square. Okay, it will always form a square. As for figure 5, it will form another square. Okay, so if you notice, this is actually 1 times 1, 1 times 1, then 3 times 3, 3 times 3. So it skipped 2 times 2. Where is 2 times 2? 2 times 2 is over here for the white. So if you look at the numbers in the table, right, they actually resemble, they are actually square numbers. Square numbers means something times something to give you that number. Okay, they form a square. So this figure number 5, right, it wouldn't be 4 times 4, but this one would be 5 times 5. Okay, so this is 25. 5 times 5. For the bottom one, it's not going to change for figure 5 because after figure 4, right, figure 4, the layer outside is white. In figure 5, the layer outside will be the gray circles, so the white wouldn't change. So this would be 16. Okay, what is the total number of gray and white circles in figure 250? Now, let's look for all the square numbers in sequence. So this is what I mean. You have 1 times 1, and here it changes to 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. You notice a pattern that it kind of like zigzag across the gray and white, right? Like alternate between gray and white. So for all the odd numbered figure number, you will have the figure number times figure number. Okay, so like figure, let's look at figure 2. Figure 3. Odd numbered figure number. Figure 3 is 3 times 3 for the gray. Figure 5 is 5 times 5 for the gray. Whereas for the white, it will be figure number times figure number for the even figure number. So what we have here is even figure number. So I know for sure that the white circles will be 250 times 250. So at least I figure one part out first, the white. So if you look at all the even numbered figure number, right, the white will be figure number times figure number, but the gray will be one less, the square of the number before. So if it's 2 times 2, then gray will be 1 times 1. If it's 4 times 4, then gray will be 3 times 3. So for figure 250, the gray would be 249 times 249. Okay, so this is actually a pretty challenging patterns question, because it not only it doesn't give you the pattern like directly, but instead you have to observe that the square numbers actually alternates between the gray and white. So I would think that most students will find this question challenging. Okay, so the answer is 124501. Add them up, white and gray. Question 12. Okay, question 12, figure 1 shows 4 identical right-angled triangles, and then figure 2 is formed from these triangles. Total perimeter of the 4 triangles in figure 1 is 160. What's the perimeter of figure 2? Okay, let's take a look at figure 2. We know that each of these, the shortest side of the triangle is 8 cm. Let's identify the 8 cm. So this is 8. This is also 8. There are more 8s, but let's just identify those two first. Look at one triangle. Okay, perimeter of all these is 160. So the perimeter of one triangle would be 160 divided by 4. 40. I need to find perimeter of figure 2, but I can't take 40 times 4 because it doesn't, you shouldn't count the 8s for each of the triangle. Okay, let me just highlight this part here and this part here. How do we find that? For this, it will be 40 minus 8 minus 8. 24. Now, how many of that makes up the perimeter of figure 2? So you have 4 of that. So we take 24 times 4. And that will give you the whole perimeter of the figure. 96 cm. Now for part B, area of figure 2 is 240 square cm. What is the length of AB? So technically, if you can find this side of the triangle, you can find AB, right? Just need to minus 8 from that. Okay, let's look at one triangle. Area of one triangle is 240 divided by 4. 60. What is 60? 60 is the area of one triangle. And to find a triangle, we take half times base times height. Okay, so half times, let's take the base as this 8. And the height is this. So half times 8 times height will give us 60. So what we do here is we take 60 times 2 and then we divide by 8. 60 times 2, then divide by 8, which is 15. So this is 15. To find AB, we take 8, 15 minus 8. So answer is 7 cm. Okay, this part here, this is 15 and minus away 8 to get AB. Question 13. Joshua received an amount of pocket money from his parents each month. Within each month, Joshua spent some of the pocket money that he received for that month and deposited the remaining into a savings box. So the graphs below shows the amount of money he spent and the amount of money he deposited into a savings box each month. This is the amount he spent. Then this is the amount that he saved. He deposited, so he saved it. Okay, then for part A, right, which is on the next page. From which month onwards was there an increase in his monthly pocket money? So his monthly pocket money would consist of what he spent and what he saved. Okay, what he spent and what he deposited. When you add them up, that will give you the monthly pocket money. Pocket money? Yeah. Okay. So for January all the way to May, let's find out how much each of these are. So reading from the graph. Each interval, take note, there are 5 intervals from 0 to 20, so each interval is a plus 4. So for January, 36, February 28, March 64, then this is 92, this is 60. Amount deposited would be 84, 92, 68, 40, and 72. So for part A, you're going to find the total amount that he saved for each month before you compare. So we need to add. Take note of the numbers. Make sure you have all these numbers correct. Then here for each of the months. So January, 36 plus 84, which is 120. For February is 28 and 92, which is also 120. For March would be 64 plus 68, which is 132. Yeah, now you observe a change, but let's calculate all in case there's any mistakes, or you can check against the numbers. So for April is also 132. So seems like there is only one increase, right? So for May is also 132. So there is an increase here. From which month? From which month onwards? So it will be from March onwards. What's the percentage increase? So percentage increase is increase over original times 100%. So the increase is 132 minus 120, 12. So increase over original means that the amount that he had before, 120, and times 100%. And that will give us 10%. In one of the months, the amount of money he spent was more than the amount of money he deposited. In that month, how much more money was spent than deposited? Okay, look for the months that he spent more than what he deposited. He spent more in April, 92 versus 40. He spent more in April than what he saved. So 92 minus 40. How much more? Then yeah, it's just 92 minus 40. 52. Answer $52 more. Okay, so if you understand the question, what they're trying to ask for, this question is actually not that difficult. Okay, if you understand what they're asking for. The question 14. Raj had an empty rectangular tank P and a cubical tank Q. He poured an equal amount of water into the tanks. After that, 1/4 of P was filled with water and 2/3 of Q was filled with water. Difference in capacity between P and Q was 5,625 cubic cm. So what's the ratio of the capacity of tank P to Q? All right, so firstly, we know that he poured in an equal amount of water. Okay, so the amount of water filled in each tank has the same volume, and that is 1/4 of P and 2/3 of Q. So I can say that 1/4 of P is actually the same as 2/3 of the capacity of Q. So equivalent proportion, always make numerator the same. Okay, so like 2 units of P goes to 2 units of Q. So 2/8 of P equals to 2/3 of Q. So I have 2 units equals 2 units. What does it tell you about the total capacity for P? It's 8 units, and the total capacity for Q is 3 units. So in terms of capacity, P to Q would be 8 to 3. Okay, and that is what we want. Ratio of the capacities. What is the length of 1/8 of tank Q? Now, tank Q is a cubical tank. Okay, all the sides are the same. So using this 5625, let's find how many units is that. That is the difference in capacity. So the difference between 8 and 3 units. So 5 units is 5625. Okay, then we find 1 unit. One, 125. Let's find capacity of Q, which is 3 units. Three, 375. If that is the volume of a cube, right? How do you find one side? You can use cube root. Or something times something times something. Okay, that one you have to use a calculator and try and get the number. But otherwise, you can use cube root, and the answer would be 15 cm. So the length of 1/8 would be 15, because 15 times 15 times 15 gives us 3375. Question number 15. Okay, we have a rectangular piece of paper here. Outline consists of a large semicircle, which is this one here. 2 smaller semicircles, which is this one here, and this over here. And then 2 identical quarter circles, which is this and this. The area of the rectangular piece of paper is 588 square cm. What is the breadth of the piece of paper? Now, we're not going to guess what is the breadth and length, but instead we're going to cut this into smaller squares, because with area of a square, I can find the sides. So they are all equal squares, and they're all equal because of like the radiuses and the diameters, they are the same. Like example, this is a semicircle. So this one cuts it into half. This side has to be the same as this side. Okay, then this one can cut into half because this is a semicircle. This would be the radius. So from here, after you cut, right, you get like 12 squares. So 12 squares is 588. 1 square is 588. Divide by 12, which is 49. If the area of a square is 49, then you can find one side, which is 7. Okay, so this is 7. The breadth of the paper would be 3 times of that. So 7 times 3. Answer 21 cm. The challenging part is the next one, part B. What is the total area of the shaded part? Okay, I'm going to shift the shaded semicircle down so that I get a big quadrant. Okay, let me redraw so that it's easier to see. So I'm trying to draw the 12 squares here. Okay, a bit of some excess lines. Then this part here, we had this semicircle on top, right? Then initially we have this. Okay, we're gonna shift this here. Such that this part here be shaded. Okay, I shift it now. Then, okay, here comes the challenging part. Let's draw this. Okay. Then we have shaded parts here. Now, can you see that we actually have a big semicircle, and then we minus away these parts here. Okay, so semicircle I can find easily, but it's this part here I need to remove. Let's call this part A, like the square is A, and then this part here is B, and this is C. A is a square, right? B plus C is actually one square as well. Because this is like the boomerang, and this is a quadrant. The quadrant plus the boomerang gives you one square. This is a small quadrant. Okay, at B you get a full square. So technically it's a big semicircle minus away 2 squares. Okay, so the shaded would be the big semicircle minus away 2 squares. Okay, let's find a big semicircle. Radius of big semicircle would be 7 times 2. 14. So this is 14. So area of the semicircle, half times pi. Pi is 22/7 according to the top part of the question. Times radius times radius. 308. Now the big semicircle is 308. I need to remove 2 squares. One square is 7 times 7, 49. 2 squares, 49 times 2, 98. So I'll take the whole semicircle minus the 2 squares, okay, to get the shaded part. So answer 210 square cm. Question 16. Mr. Lee bought a total of 38 small and big boxes of nuggets. Each small box of nuggets cost $6.30, while each big box of nuggets cost $9.75. He paid $287.85 after a discount of $4 for every $50 spent. What was the total cost of the box of nuggets before the discount? All right, we know after discount is 287.85. Okay, so we need to find like what's the amount before discount. So what we're going to do is we're going to add back the discount. Okay, so for every 50 that is spent, you get a discount of 4. So you're not actually paying 50 whenever you have an amount, whenever it amounts up to 50, you don't exactly pay 50. How much do you pay? You pay 50 minus 4, which is 46. So like every group of 46 in the final amount that he spent means that he actually received a discount of $4. So how many groups are there? So the number of groups would be the total amount divide by 46. Okay, you want to find out how many times of 46 are there. Because for every 46, every group of $46, he received a $4 discount. You press in your calculator, you should get a 6 point something. I want the remainder. Just find it with a remainder. So 6 groups of $46 is how much? And then take that, minus it off from 287.85. You should get a remainder of $11.85. Okay, so I'm interested in this 6 groups means that I received the discount of $4 6 times. So the discount would be 6 times of $4. 24. So he received $24 of discount. Add that back to the amount that he paid. And you will get the original cost before discount. 311.85. How many small boxes did he buy? Okay, this is actually supposition question for part B. Total amount spent is 311.85. Total number of boxes will be 38. We're looking for small, so we suppose all are big boxes. So if you take 38 as big boxes, right? So 38 times the total amount, 38 big boxes will be 38 times 975. This will give us 370.50. Okay, but this would be if everything is big. Okay, but actually no, the total is only 311.85. So the difference that the difference that we want to remove, then you minus off the difference that you want to remove. or the extra that you want to remove would be $58.65. Okay, the extra. Uh, okay, so this means that not everything will be big boxes, right? Some of them will be small. So we have to do an exchange. And every exchange, how much do we lose when we exchange one big for one small? Every big is 9.75, every small is 6.30. So 9.75 minus 6.30. $3.45. And the number of exchanges, so the number of times you have to do this exchange, right, would be this extra that you want to remove divided by the amount that you remove for every exchange. So 58.65 divide by 345. So you get 17. 17 is the number of times you exchange from big to small. So 17 is also the number of small boxes. Okay, and that's the answer. Question 17. Okay, this is also a challenging question. Okay, Abel used sticks to make some stars and Brenda used some sticks to make some triangles. So Abel used 10 sticks to make each star, 6 sticks to make Brenda used 6 sticks to make each triangle. Abel made 7 fewer shapes than Brenda and used 10 more sticks than Brenda. How many stars did Abel make? Okay, so there are two things you need to take note of. One is the number of shapes, right? Okay, number of shapes. The other one is the number of sticks. So number of shapes, we refer to it as quantity. So in terms of quantity, it will be this. Abel made 7 fewer. Okay, so Abel made the stars, Brenda made the triangle. So A for the stars, B the triangles. A is 7 fewer. So there's 7. Then in terms of value, use 10 more than Brenda. Okay. A use 10 more than B. A is 10 more than B. Okay, from here, what I want to do is I want to remove the extra quantity, which is the 7 triangles. Okay, the 7 triangles is the extra. So 7 triangles would be how many sticks? 7 times each triangle is 6 sticks. So this is 42. I want to remove 42 sticks from this model. Okay, this model talks about the sticks. So I remove from triangle. So from here, what can you say about the difference now? Is it still 10? Did it become bigger or did it become smaller? So the new difference that I have after removing the extra quantities, I have, this is what we call new total difference, TD for short, new total difference. it becomes 10 plus 42. So it will be easier to see if you have a model there that the difference has actually increased. So now I know that the quantity is the same because I've removed these 7 extra triangles, right? So with the same quantity, I can do grouping. So grouping will look like that. I have 1 star, 1 triangle in each group. I have many groups, and all this will give me a difference, a total difference of total difference of 52 sticks. Okay, so from here is grouping. In one group, I will be finding the difference. 1 star versus 1 triangle, meaning 10 sticks minus 6 sticks. Difference is 4 sticks. So number of groups. So you see every group, the difference is 4 sticks, right? But the total difference is actually 52. So how many groups are there? So 4, 4, 4, 4, 4, 4 until you get 52. So we take 52 divided by 4, which is 13. There are 13 groups. Question is asking how many stars did Abel make? In one group, you have 1 star. So if there are 13 groups, it's 13 times 1. Okay, so answer 13 stars. Part B, how many sticks did Brenda use to make all her triangles? So for Brenda, how many triangles did she make? Remember, we took away 7 triangles. You will have to add it back now. So number of triangles would be 13 plus 7, 20. Every triangle requires 6 sticks. So 20 times 6. Answer 120. Okay, so this is how you do question 17. So with that, that's the end for this paper. This is Catholic High Prelim paper for 2024, paper 2.